Good morning. My name is Luke Van Hurl. I'm the Director of Global Sales and Service for Kinze Manufacturing out of Williamsburg, Iowa. And of course you're here on our booth at the Farm Progress Show in Decatur, Illinois. We're standing in front of our brand new 4900 model planter, and we're very excited about it. And when people ask us what's new about it, it's just about everything. So let's be a little bit more specific. The frame of a planter, which is called a toolbar, is really where it all begins. And as you can see here, what we did is we built in all the features that our farmer customers had been asking for. They had been asking for more flex. In other words, that's the ability of the frame of the planter to follow contours and terraces. So we tried to demonstrate that here by building these artificial hills. And this particular frame flexes 21 degrees up and 21 degrees down, which is incredibly a lot. One customer yesterday asked, now look, if you plant it like this, how would you harvest that? Well, that's no longer our problem, but you probably wouldn't plant like this. We're just trying to demonstrate what it can do. So the first thing we did is build in a lot of flex into the frame. We also built the frame higher, about 4 inches higher than what has been the norm up until now. And the reason we did that is obviously you're getting more and more no-till or minimum till practices. What that does is that leaves stalks in the field that are as hard as concrete and really difficult to grasp it. So by moving the toolbar higher, it leaves more room to give your row unit up and down travel, and also to bypass some of that trash that's left in the fields from the year before. So when you build this much flex into a planter, one of the challenges that comes with that, as you have central fill, bulk fill for seed and central fill liquid fertilizer capacity, is how do you disperse the weight that you have in the center of this planter all the way out to the left and right wing of the planter, because it's very important that you have about the same weight distributed over every single one of these row units. The reason you need that is what controls the depth at which you plant, which is critical. There are three things you absolutely have to do when you plant. You have to have the right seed depth, you have to have the right seed spacing, and then when it's all said and done, you have to cover that seed so you have good seed to soil contact. And the hydraulic weight transfer feature, which is really central to the success of this planter. There are two horizontally placed hydraulic cylinders that disperse the weight from underneath the center of the frame where all this weight is centralized, and they move it out to the wings of the planter. Again, this is what ensures even down pressure on all your individual row units. Which brings me to the row units. That's the other thing that is important and new and different about this planter. Since we raised the toolbar by 4 inches, we had to obviously go and create a new row unit. Of course, row units have been around, and we kind of invented the principle 30 years ago. So what do you do? What do you do to make them better? Well, since we went for a much higher speed capacity, this planter, we talk about 99% plus accuracy at up to 8 miles an hour, which is substantially faster than had been planted before. When you go faster, all of a sudden the forces increase by a factor of 2 or 3. So you have to make this row unit a lot more durable. So we went to a cast iron row unit like you see here, instead of having a welded steel row unit. And then of course the heart and soul of this thing is the meter. We went to a whole new meter, and that will be easier for me to demonstrate outside in our tent. As we mentioned when we were standing by the planter, the other great big innovation about this planter is its meter. We've come out with an entirely new meter, grounds up design, everything about it is new. This is a meter, and of course every row unit would have one of these. And those of you who know meters will immediately see what's different about this meter. It is this right here. This is an electric drive. So this is not a ground drive meter driven by a shaft or a chain. This is not a hydraulic meter. This is an electric meter, which has all sorts of features, but think about what an electric motor can do. It stops and starts instantly. You can vary its speed infinitely. You can vary each row's speed infinitely. So you now have all of a sudden the capability to do variable rate planting everywhere you go. You can go around a corner and the outer row will be planting at exactly the same spacing as the inner row, even though it is running a lot faster than the inner row is. Along with that, we changed everything about the inside of this meter as well. Here we're using a clear housing for demonstration purposes, obviously, but inside of this is a disc. That's what holds the seed. So you have vacuum that holds the seed onto the disc as this disc rotates, and then when it gets near where the seed tube is, the vacuum is cut off, which of course makes the seed drop in the tube. We changed the shape of the disc so that it would hold the seed in an elevated position, and what that does is it makes sure that it drops when it's supposed to, and it also makes sure that you only have one seed in that hole instead of several. That's what's called cingulation. You just want one seed. And of course, because we are marketing this meter as capable of up to 8 miles an hour speeds, you have to be able to do this very fast. You know, in some instances you're talking about 17 or 19 seeds per second that you still need to plant at 2 inches depth, 6.5 inches apart, and it's the accuracy of that that makes it important. We did a test run here. As you can see, we typically get somewhere between 99.5% and 100% cingulation. The other thing we changed was the cingulator. That's this device up front here, and just as the word implies, a cingulator does just that. It makes sure that you have only one seed and one seed only on every one of those openings, so it pushes every other seed out of the way. This one is adjustable depending on which crop you're using, whether it's corn or soybeans, and obviously for soybeans, which is a much smaller seed, you have slightly more aggressive cingulation so that it pushes those smaller seeds off of there that don't belong there. We also changed the seed pool. Just about everything you looked at is different, and that's why we talk about 99% plus accuracy at 8 miles an hour, which is incredible. Why is that important? Well, farms are getting larger. We still only have about 10 days of the year that are ideal weather conditions to plant. So larger farm, 10 days, what do you need to do? You need to be able to plant more efficiently, plant more acres in one day without losing any of the accuracy that you need, because it's the accuracy that's going to maximize the yield that you need at the end of the season when you go and harvest it. Here's our new meter. Let me run it for you. And you can see on the screen, you know, we're still at 100%. A typical test run is 1,000 seeds, so it will run until it gets to about 1,000. We're still at perfection right now, 100%. No skips, no doubles. We've got it set at 5.8 miles an hour, 35,000, which is a fairly high population. So there you have it, the all-new Kinze 4900 planter with the 4000 series meter on it. Go check it out on our website, www.kinze.com. Get all the specifications and details, and of course go and talk to your local Kinze dealer about it. Thank you very much.
This video is brought to you by Farms.com.